Now in the last lecture we have seen the effect of negative feedback on input and output resistance of the voltage series we have seen. Now we will see the voltage shunt. Now on voltage shunt feedback, how the input and output resistance how it varies with the negative feedback, we will see in this lecture. Now here I am drawing the block diagram of voltage shunt. So here I am taking the amplifier with a gain of A, feedback network with the beta factor. Now first we will take in this heading, first term indicates the output side. Output is voltage. So sample we are taking as a voltage. So to take the same voltage we need to connect this shunt connection. Now here same voltage V0 we can get by making the shunt connection. Now this is RL. Now input side is shunt again. Input side is shunt means which source we need to apply. So now here which source we have to apply? Input side we have to apply the current source. Why? Because in a shunt only currents can be added and subtracted. Voltages are same. That's why input side it is a mixing. So what can be mixing, how it possible? When you take the current source. That's why here we have to take the current source. This is the current source IF. This is the current source IS. IS, and this is the II. Now input parameter current. Now here this is the feedback IF. IF is going down. So this is the negative feedback. That's why we have to take the arrow mark downwards. Now here for this, if I draw the equivalent diagram. Now for amplifier, how to draw? If it is a voltage amplifier or current amplifier, both for any amplifier circuit, we have to represent with the resistor only. Simply input side it is resistor Ri. And output side, if you see, output side we are taking the voltage. So we have to represent with the dependent voltage source in series with the resistor. Now this is R0. This is nothing but what? This is the amplifier equivalent diagram. This is the amplifier equivalent diagram. For this amplifier, what is the input resistance? Ri is the input resistance and R0 is the output resistance. Now here I am applying the input source and load. So output side I am connecting the load RL, and here the voltage is V0. And input side if you see IS, current source we have to connect. So this is the IS. Current direction is in this direction. Now here this is the IF feedback. This is IF. It is a leaving current, and this is the II. Now from this diagram, what can we write? A is equal to output by input. Output is V0, input is II. And beta is equal to output by input. For this feedback network, what is output? IF is the output. And what is the input? V0 is the input. Now from this expression, II is equal to what can I write? II is equal to, this is the negative feedback. So always the feedback signal is subtracted from the input source, Is minus IF. Now these three are the expression. Now from this expression, V0 is equal to what can we write? IF is equal to what can we write? IF is equal to beta times V0. Now from this expression, V0 is equal to what can we write? A into II. A into II. Now if I am looking from this point into the amplifier, so resistance Ri is equal to what can I write? Now all are the supplies. Now here the voltage is V I am taking, because this is shunt connection. In a shunt voltages are same. That's why I am representing the voltage with V. So V divided by II. Now if I am looking from this point after the feedback, then RIF with the feedback means what? RIF denotation is F. So V divided by IS. Now this is the two resistance. Now first we need to write the input expression II. II is equal to what can we write? II is equal to IS minus IF. Now where IF is equal to what can we write? Beta times V0. II is equal to IS minus beta times V0. Now again V0 is equal to what can we write? II is equal to IS minus. If you are taking the input side, if it is a current source, it is a node. So it is node, if you apply the KCL at this point, at this node, entering currents is equal to leaving currents. Like that also you can write this expression. Now IS minus A beta II. Now from the first expression, there, from the first expression. Now II terms you write together and take out II, then we will get II of 1 plus A beta is equal to IS. Now what can we write? II is equal to what can we write? II is equal to V divided by Ri into 1 plus A beta. So IS is equal to what can we write? V divided by RIF. Now both the sides cancel the V, and if you take RIF is equal to what can we write? Now RIF is equal to Ri divided by 1 plus A beta. So with the negative feedback, what happened? The input resistance decreased by 1 plus A beta times. Now input side is the current source. If the input, how much input resistance is less, that much the supply current will flow through the amplifier, thereby it will amplify and it will give the output. So in the voltage shunt, so input resistance should be less. With the negative feedback, further it reduced. Now this is the effect on the input resistance. Similarly, we have to calculate the RIF. Now for that, what are the two conditions for to calculate the output resistance R0F? For that, what are the two conditions? Remove the load where we need to calculate the resistance. Now here I am calculating the resistance R0F. There you have to remove the load V0 divided by I0. Now here this is nothing but a I0. And also input current. So first condition is what? Make RL is equal to infinite, open it. And second term is what? IS is equal to 0. If it is a voltage source, short it. Now if it is a current source, open it. Now just you have to open like this. Now if I rewrite the input expression, then already what we have taken, II is equal to IS minus IF. In this, if you put IS is equal to 0, what you will get? II is equal to minus IF. Otherwise, if you apply the KVL here, it is a leaving current. Both are leaving currents. If you take it IF plus II is equal to 0, then you will get II is equal to minus IF. Now from this, what can we write? IF is equal to what can we write? Beta times V0. Now take the KCL at the output. Now apply KCL at the output. Apply KVL at output loop. Then if I write the expression I0 is equal to what can I write? I0 is leaving the current from the V0. So first I have to take the V0 minus, and what is this dependent source? This is nothing but A into input parameter. What is the input parameter? Input is AI. So II. So A into II. So now here V0 minus A into II divided by R0. So now in this, now apply AI is equal to beta V0. So here it is a minus IF. So minus we will get. So I0 is equal to V0 plus A beta V0 divided by R0. Now V0 term take out and write the expression V0 divided by I0. Then we get, now I0 is equal to what can we write? I0 is equal to V0 I am taking out. So 1 plus A beta divided by R0. So V0 by I0. So V0 by I0 is equal to R0 divided by 1 plus A beta. Now this V0 by I0 is nothing but what? R0F. R0F is equal to R0 divided by 1 plus A beta. Now with this what we understood? So with the negative feedback, further the output voltage reduces. Now this is the amplifier. After the amplification, now the complete signal should go to the load, should not dropped by the internal resistance. So with the negative feedback, what happens? Further the output resistance is reduced. So this is the effect of negative feedback on voltage shunt on both the input side and output side. Both input and output reduced by 1 plus A beta times. Thank you.